This is a demonstration of two different machines that work nicely together as a combo. The one on the right is a Digi-Payoff, a programmable payoff machine for feeding off fine wires and filaments into a process that pulls it. And on the left is a pull-n-spool take-up unit, which features a servo-driven belt capstan that pulls the wire, in this case, at a very precise speed and then winds it up at a desired tension onto a take-up spool. So normally you can see there's a gap between the two machines, and these two will be going out together to the same customer, and there will be an extruder in between them for a extruder application. So here we are, we're pulling with the pull-n-spool, and you can see on the payoff we've got a desired tension of 50 grams, and you can see to the right of that is our actual tension, which it's maintaining plus or minus 2 or 3 grams at all times. And that's something I can change on the fly. I can go down to 40 if I want, and you'll see it make an adjustment. It's green when it's within range of a few grams. It turns red if it goes out of range. I'll go back up to 50. So I'll go red, then green again. And you can see also we can set a speed on there, which actually is being ignored at the moment because the speed is being dictated by the puller, and this will do whatever it has to maintain the tension. It's also tracking length. If you look a little closer here on the machine, it's got a servo on the payoff. The wire is being fed down to a tension transducer. In this case, we're using a solid state transducer with a range up to about 500 grams. And that's just one of a few different tension solutions we have. We also have a couple dancers for much lower or higher tension depending on the requirement. We can get down to about 5 grams with these machines. When we have a solid state tension transducer, we also introduce some compliance with a dampener that will just absorb any inconsistencies really coming off of the spool that we need to absorb. Down below that is an encoder based length tracker, and then we're feeding over to the capstan unit or the puller, and again servo on the back of the capstan. This is another length tracker with a wire break detector, and you can see we're winding up nicely here. So right now we're running at 50 feet per minute. It can also go very slow if that's the need. We'll go down to 5 feet per minute, and now you can see things moving very slowly, but we're still maintaining our tension. If I want to, I can jump up to a faster speed. Let's go up to 150. It'll accelerate gradually up to that speed. And if you watch the whole time, we're still keeping our tension. And by the way, I glossed over the fact that you can set a speed on here. The reason for that is, in this case, we had an ideal scenario where I was able to attach the wire to my take-up, and that would do the pulling, and this would do whatever it has to maintain the tension. There's some cases where you need to attach the wire on the fly, where it'd be coming off of here. You need to feed it through a process, get it attached to a take-up spool, and then let them synchronize. So this speed on here would be an approximation of what you need to be going to get them synchronized, and you can step it up or down as needed with those keys. And then once you got them close, you synchronize it by pressing that tension button. But anyway, so here we are. We're 150 feet per minute. Let's jump up to 250. And also 350. So you can see we're climbing up to that. And take a look over here. Our tension is still good. One other feature of the Pull-n-Spool, let me slow it down so it's not quite as noisy. Another feature is our ability to read in an analog input, usually from a laser micrometer, where we can enter into our controller desired diameter, down to the micron, and this puller will respond to the analog output from that laser to affect the final diameter of a product, typically coming out of either an extruder or even a fiber optic draw tower, which was the original intention of this unit, but it's very versatile. Then you can see here also we have our speed control. That's the base speed of our take-up, but the truth is it's slipping at a desired tension that is set here. There's an electronic clutch internally in there. So that's it. You've got the Digi-Payoff on the right and a Pull-n-Spool on the left.